What's up everyone, Patrick here, welcome back. And in this question we're asked how many asymptotes does this function 3x minus x squared over x squared minus 9 have? So with this kind of question you got to be careful because, let me rewrite it here, you might be tempted to look at this question, factor the denominator, which is what you got to do. That's a difference of squares, x plus 3, x minus 3. You might look at this here and you might say, well, there's two vertical asymptotes, one at 3 and then one at negative 3, right? These two x values make the denominator equal to 0. But that conclusion would be incorrect. Why? Because you got to factor the numerator as well. And you got to see that there may be factors that potentially cancel out in the numerator and denominator. And if you remember, when that happens, that means that the function has a hole at that point, at that x value, not a vertical asymptote. So notice that at the top here, I can factor out an x, and then I got x plus 3, x minus 3. So notice now, looking at this function, there are two x values that make the denominator equal to 0. But notice that one of the x values, more specifically x equals 3, makes the numerator equal to 0 as well. Right? This would be 0 at an x value 3, and then this would be 0 at an x value 3. Which means that at that point, x equals 3, there's going to be a hole and not a vertical asymptote. And to show how they factor out, right now, 3 minus x, x minus 3 are not the same thing, but we could factor out a negative from this bracket. And now notice the x minus 3's cancel out. And so what this function here is if we fully simplify it, it's basically this function, right, with a hole at an x value of 3, like that. Okay, so this function here, notice that it has a vertical asymptote at an x value of negative 3. That x value makes the denominator 0. And notice that there's a horizontal asymptote. And the horizontal asymptote is y equals the ratio of the leading coefficients. So we got negative 1 over 1. So this is negative 1 right there. Right, so those are the two asymptotes in this case. There's one vertical asymptote, one horizontal asymptote, versus if you didn't factor and notice that there's these two factors canceling out, you might look at that and think there's two vertical asymptotes and then one horizontal asymptote at the ratio of the leading coefficients, negative 1. But in fact, there's only one vertical asymptote. So if you were to graph this quickly, there's a vertical asymptote at x equals negative 3. There's, it's going to go through the origin, and then there's a horizontal asymptote at negative 1 like this. So basically this function looks like this. Okay, but at an x value of 3, so let's say the x value of 3 there, there's a hole. All right, so two asymptotes in this case, and more specifically, one vertical asymptote at x equals negative 3, one horizontal asymptote at y equals negative 1.